Good evening, friends. Now we are discussing problems on Mach number in the compressible fluid flow. On the basis of the Mach number, the compressible fluid flow will be classified as subsonic, sonic flow, and supersonic flow. Subsonic flow is the case of when Mach number is less than 1. So, Mach number is the ratio of V to C. So, where V is the velocity of the flow of the projectile and C is the velocity of the sound wave or the disturbance wave. So, V divided by C is less than 1. So, V is less than C. That is, the velocity of flow is less than velocity of the sound wave in the case of subsonic flow. And in a sonic flow is the case when m is equal to 1, that is the Mach number is equal to 1. So V divided by C is equal to 1. So V is equal to C. Then supersonic flow, that is the Mach number is greater than 1. So that is V by C is greater than 1. So V is greater than C. So when we take the numerical problems, you will have a better idea about the type of the flow. Now, sorry, the problem 1 is asked to find the sonic velocity of the given fluids here. There are two parts in the given problem. So one is the crude oil of specific gravity 0.8 and the bulk modulus is given in Newton per centimeter square. The second part of the same problem is the liquid given is mercury having the bulk modulus in Newton per centimeter square. You are asked to find the sonic velocity. Sonic velocity in the sense the Mach number is equal to 1. Sorry. Now the crude oil is given with the specific gravity 0.8. So density is now 0.8 into 1000, so that comes to 800 kg per meter cube. So bulk modulus is given in Newton per centimeter square. So this is converted into meter square. So that is 10 to the power of minus 2 to the power of 2. It becomes 10 to the power of minus 4 in the denominator, which goes up to become 10 to the power of 4 Newton per meter square. Now for the crude oil, the velocity of the crude oil flow is given as square root of since bulk modulus is given in the statement of the problem, we are taking the equation of velocity of the compressible flow with the bulk modulus in the equation, that is square root of k divided by rho. So that is the density. K is the bulk modulus given, substituted here. Density is found out. So specific gravity is given. So that is by default multiplied by the density of the standard liquid, so that is water. Its density is 1000 kg per meter cube. So it states that the oil is 0.8 times denser than the standard liquid, that is the water. So its density is now 800 kg per meter cube, that is substituted to get the sonic velocity as this in meter per second. The second part of the problem is on mercury. So even if it is not given in the statement of the problem, so it is necessary to memorize because mercury is the heaviest liquid which we know. So its specific gravity is 13.6 to be memorized. So its density is now 13.6 into 1000 kg per meter cube, and the bulk modulus of the mercury is given in Newton per centimeter square. If it is given, converted into Newton per meter square. Now the sonic velocity equation is square root of k by rho, substituting rho and k. So we are getting velocity of this mercury flow as so many meter per second. Now the next problem is an aeroplane which is flying at a height of 15 kilometer where the temperature is minus 50 degrees centigrade. The speed of the plane is corresponding to the Mach number of 2. Assuming K is 1.4 here, so K is the constant of specific heat, so that is small k. So bulk modulus is capital K, and this small k is the constant of specific heat, and this gas constant, so that is 287 joules per kg Kelvin. So you are asked to find the speed of the plane. So to calculate the speed of the plane, so we need the Mach number equation. So that is m is equal to v by c. So where v is the velocity of the object and c is the velocity of the sound wave. Here the object given is the plane, so its velocity to be found out. So Mach number is given. First we need to find out the velocity of the sound. So that is having the equation. So we have different equation for the sound waves. Since the constant of specific heat is given in the statement, we consider this as adiabatic process having the equation of square root of kRT here. So we have the height of the plane given in the data, that is 15 kilometer above the ground. So that is extra data, we are not using anywhere this. Temperature is given as minus 50 degrees centigrade, that should be converted into degree Kelvin. So capital T is equal to 273 plus or minus 3 degrees centigrade. So minus 50, so it is 223 degree Kelvin. So the other data given are Mach number, then constant of specific heat, and gas constant are given. So those things are substituted in velocity of sound equation, so that velocity of the sound, that is when the plane is flying in the air, so the sound produced by the plane is traveling at a velocity of 299.33 meter per second. Now it is we are finding here the velocity of the plane. So that is substituting m and c. So we are getting velocity of the plane as so many meter per second. So that is converted into kilometer per hour. So that is meter is converted to kilometer. That is multiply by 10 to the power of minus 3 here, and 60. Sorry, second is converted into hours. So that is 60 into 60. So that is coming into the numerator. So finally we'll have 2155.17 kilometer per hour. Otherwise, the answer can be left with the unit of meter per second. Thank you.